Cool. Altitude on the hypotenuse theorems. Don't cop an altitude. Alright, so geometric means in right triangles. In a right triangle, an altitude drawn from the vertex of the right angle to the hypotenuse forms two additional right triangles. And these three right triangles share a very special. Okay, so if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle formed and to each other. So in our drawing here, if segment CD is the altitude to hypotenuse segment AB of right triangle ABC, then triangle ACD is similar to triangle ABC, triangle CBD is similar to triangle ABC, and triangle ACD is similar to triangle CBD. And then we could actually make that a big old transitive thing, right? We could say that triangle ABC is similar to triangle CBD is similar to triangle ACD. And you'll notice those are in red and in blue because we have cool animation to show what we're looking at. All right. So here we have a drawing of triangle ABC again, with C being the right angle, and we are drawing an altitude from segment CD. Okay, so we've got a number of different angle measurements or segment measurements here. We've got A, B, and C, right, from Pythagorean theorem. The A is a leg, B is a leg, C is a leg, but H is the altitude, and X and Y are the two segments that the altitude divides the hypotenuse into. Okay, so if we look at the large right triangle and we compare the shorter leg to the longer leg, the ratios, well, in the smaller triangle, that's going to be y over h, and in the let's say the mid-sized triangle, that would be h over x. So slide that over there. And let's say I wanted to compare the hypotenuse to the shorter leg. Well, in the large triangle, that would be c over a, and that would be equal to a over y, which is equal to b over h. Okay, slide that over, and let's compare the hypotenuse to the longer leg. So in the large triangle, that's c over b. In the mid-sized triangle, that's b over x, and in the small triangle, that's a to h. So in all three of these extended proportions, we have a geometric mean. Are you digging that animation there, huh? That is something. I am a PowerPoint stud. Anyways, we have geometric means involved. So, whoa, go back. Okay, wait a minute. Quit goofing around. Sit still. All right. So, quick way to remember this is that h is the geometric mean between these two. A is going to be the geometric mean between y and c, or the segment that's by it, and the hypotenuse of the large triangle. B is going to be the geometric mean between the segment and, again, the length of the hypotenuse of the large right triangle. Oh, look at that mess that this thing left. Clean up after itself here. So, Theorem 68b is the altitude drawn to the hypotenuse is a mean proportional between the segments of the hypotenuse. So if segment CD is the altitude to the hypotenuse of segment AB of right triangle ABC, then x over h equals h over y, or h squared is equal to xy. And you're going to have to know all these. Theorem 68c is either leg of the given right triangle is the mean proportional between the hypotenuse of the given right triangle and the segment of the hypotenuse adjacent to that leg. And just like we showed you before, y over a equals a over c, and a squared equals yc, and x over b equals b over c, and b squared equals xc. All right, so let's do some math. So again, we talked about this. The altitude itself is the geometric mean between those two segments. So we're going to set this up as 3 over x equals x over 9. So x squared is going to equal 27. Now, we are going to take the square root of each side of this. And I'm going to end up with x is equal to the square root of 27. Now, you're not allowed to stop there because you're big boys and you're in honors. So we're going to simplify those radicals. So we're going to take, this is the square root of 9 times the square root of 3. And I end up with x equal to 3 times the square root of 3. So that's our final answer. Now, in this case, we know that AC, the length of AC is x, and that's going to be the geometric mean between this segment and the hypotenuse. Well, there's no measurement for the hypotenuse, but I know that 3 plus 9 is 12, so we know it's 12. So we're going to set this back up again. 3 over x equals x over 12. Therefore, x squared is equal to 36. So again, we're going to take the square root of each side of this. And we're going to end up with x is equal to positive 6. Now, in Algebra 2 with trig next year, you'll do some work where, hey, the square root of 36 is equal to positive 6 and negative 6. Well, first of all, in geometry, it doesn't work real well because negative numbers cannot be a length of anything. So you can't have a negative length, so it's not going to even bother with it. So x is 6, that's our answer. So let's move on. Okay, so if dB equals 21 and AC equals 10, find AD. Well, the first thing we need to do, though, now we've got to keep in mind with this is the geometric mean here between this segment and the hypotenuse, but we don't have the hypotenuse length. So we know it's x plus 21, because that's what they gave us in the picture. So we're going to set this up as x over 10 equals 10 over x plus 21. So we're going to cross multiply now, and we end up with x squared plus 21x equals 100. Subtract 100 from each side, I get x squared plus 21x minus 100 equals 0. So now we're going to go ahead and factor this. The factors of negative 100 that add up to positive 21, or that are 4 apart. Well, that's pretty easy. That's going to be x plus 25 and x minus 4 equals 0. So we set both of these equal to 0. I got x plus 25 equals 0, and x minus 4 equals 0. So I get x is equal to negative 25 or positive 4. Well, we already know that because we can't have a negative value, this is out. So the value of x has got to be 4. And so that's what our final answer is. Here's a proof using this concept. So basically we want to be able to prove that PO times PM is equal to PR times PJ. So given PK is perpendicular to JM, so they're going to say that angle PKJ is a right angle and angle PKM is a right angle because perpendicular segments form right angles, the definition of perpendicular. Again with the given. So now we're going to say that segment RK is an altitude because the segment drawn from the vertex of a triangle perpendicular opposite side is an altitude, definition of altitude. And then we're going to say PK squared equals PR over PJ. Basically what this is theorem, whatever it is, I can't remember what that was, 68, whatever it is. But basically we would call that altitude hypotenuse theorem. That's fine by me with on a proof. Okay. Then we would do the same thing. They're repeating this here, that PK is squared is equal also to PO times RM PM. Therefore, this is transitive. I could also say that this would be substitution. So we're going to call this altitude hypotenuse theorem. I don't want to read all this. I don't want all that. Okay, and then this here I would say this would more be substitution, and it would transitive. Anyway.
That's all, folks.
Do the homework, learn the material. Have a great night.